Welcome to Data Center Insights with Kamal. So today I will explain liquid cooling in data centers in a very simple way. So as server density increases, especially with AI, high performance computing, cooling become a major challenge. So liquid cooling helps remove heat more efficiently than traditional air conditioning. So why the liquid cooling and what is the need of the liquid cooling? So modern server generates much higher heat compared to the traditional IT equipment, has limitations where the rack density increases beyond 40 kilowatt or 30 kilowatts. So the liquid cooling can carry the more heat using the less energy, which improve power usage effectiveness or the PUE. And it also supports AI, machine learnings, and high performance workload while reducing the cooling space or the type of liquid cooling. So modern data centers use several liquid cooling techniques to support the high density and AI workload. The first and the most widely adopted method is direct to chip cooling. Direct to chip cooling, where the liquid is delivered directly to the processor. Okay, and the the second approach is immersion cooling, where the entire servers operate inside the non-conductive cooling liquid. Another important solution is the rear door heat exchanger, which use liquid cooled door at the back of the racks. Okay. So first one is direct to chip cooling. The direct to chip cooling is the most commonly used liquid cooling method today. So in this approach, the cold plates are directly mounted on the servers or GPUs or CPUs inside the racks. Okay, and these cold plates is removing the heat right at the source, and you can see the blue line and the red lines. Actually these are the refrigerant pipeline, which is connected to refrigerant or liquid pipelines, which is connected to the directly to the cold plates, and the cold plate is taking heat from the servers or GPUs, and it is transferring the heat or rejecting the heat to the refrigerant, and refrigerant is uh, rejecting the heat inside the CDUs. Okay, and this CDUs again is transferring the heat or rejecting the heat to the facility side cooling systems such as chillers and cooling towers, and the basic uh, you know control of the flow and temperature, it is being controlled by the CDUs, the coolant distribution unit. So this is a closed loop. There are two closed loops, one in between the CDU and chillers and cooling towers, and a second one is the closed loop in between these cold plates to the CDU. And this closed loop actually is maybe the open loop or the closed loop. It depends on what types of heat rejections you have selected. So this is the basic of the direct to chip cooling. So this is the second type of liquid cooling, immersion cooling. So in immersion cooling, the entire servers are placed inside a sealed tank. This is a sealed tank, and sealed tank filled with a non-conductive dielectric fluid. So heat generated by IT equipments is absorbed directly by the liquid surrounding the servers. Okay, and the warmed liquid is circulated through an immersion liquid distribution unit where the heat is transferred. So this is the third one, rear door heat exchanger. Actually, the rear door heat exchangers are liquid cool door. Liquid cool door are installed at the rear of the server racks. Okay, here. and the hot air from the server passes through the heat exchangers where heat is transferred to a water-based cooling loop. This one. So similarly here also we have a heat exchanger, then the air is transferred the heat to the heat exchanger, then the hot water is circulating to the CDUs, and in the CDUs it is transferred the heat from this loop to the cooling tower or chiller loop, and this is the basic diagrams for the rare heat exchanger. Basically it is required where we have a existing setup and the air handling units or the air cooling systems is not capable to handle the heat load. So without disturbing the hardware, IT hardware, it is okay. So if the temperature of the air is very high when it is passes through the servers, then it is pre-cooled. It is pre-cooled by the heat exchanger before entering to the existing power setups. So this is the basic of the heat exchangers. Okay. So to conclude, liquid cooling is becoming essential for modern data centers. It enables high performance, better energy efficiency, and sustainability. As IT workload continue to grow, liquid cooling will play a key role in future ready data centers. Thank you for watching my video.